Well, good afternoon, everybody. I hope everyone's woken up from their post-lunch blues and I'm able to enthrall you with some really interesting things that are going on at Land Information New Zealand. Just as a way of introduction, I'm Jeremy Palmer. I'm the technology lead at Toitu Te Whenua Land Information New Zealand. We're responsible in New Zealand for many of the national geospatial activities, including property land register, topographic, hydrographic mapping and charting, also Crown land, biosecurity with some of our other government partners, street addressing and geodesy, and many other things as well. So as you can see, LINZ is in quite a unique position. We have quite a few things going on, but that's actually also created quite a few problems for us over the years. Because of all those business domains, we have built up a huge amount of, I guess, technology legacy, which have come from siloed areas. So today I want to tell you about our continuing journey and where we're going to in the future to try and rationalise that and bring it forward into a future geospatial cloud native world. This change which I'm sort of proposing and we're sort of part way through is more than just the technology things. It's also about the people and the cultural changes. So I plan to touch on that as well as the business benefits that we're getting going through that process. So what are our challenges? Well, we've got a very fragmented application ecosystem, as I described. You just heard I rattled off quite a few business areas that we have. We have roughly around about 140 applications, which are like delivering all of that stuff. Now they're not like all full-on applications. Some of those are like point-to-point scripts, little tools and things that we've built up, but they're all things that we have to maintain and build a lot of legacy and overhead for us. So that's one of our biggest issues that we're dealing with today. You talk to any of the people from LINZ and that definitely be one of the top of mind things when it comes to technology. We're also, New Zealand and most government departments, we're all under the cosh from central government, reduce the spend, reduce the head count, you've got to do more with less. That's typically what everybody is under. We're particularly under that pressure at the moment, so that's also a big constraint. We've got huge amounts of technical debt, so we've got fragmentation, but we've also got some technologies that were built like in the 90s. Like we've got things running on Perl CGI scripts still. So some of that stuff is still there, and while it's still robust, it's actually getting harder and harder to get people to maintain that stuff. Really, what I'm presenting today is one of really the first kind of like architectural visions which tries to bring everything together, how we're going to deliver our services to the New Zealand customer and citizen. We haven't had that cohesive picture. We haven't really looked at everything from the bottom up and come up with a cohesive architectural view. So that's also been one of our challenges, because if you don't know where you're going, then things just kind of happen organically by themselves and you can't bring them together. We haven't naturally had a common place to put all of our data and information together across all of our areas. Maybe from the sort of the outside, when you see like some of the services that we provide, you assume that we have that, but we actually don't. So we've got a lot of fragmentation internally. A lot of our internal teams don't even know where some of our data is or how to get it. There's like sharing of desktops, talking to people, USB sticks, copying files over file shares, all those things that are going on. So we still suffer from that in some regard. We are moving towards the right direction, but we haven't got those key data internal platforms. And also, and this is probably systematic, I guess, of government, although I like to think that LINZ is a little bit more forward-thinking than some of the other government departments that we have in New Zealand, but we're very slow to adopt technology. Some of those barriers like limit innovation also cause certain people not to want to work in government as well, so that's also a bit of a problem. So given all those problems, what do we want to do? Well, talking across our leadership and with all of the work leads, we really want to try and transform everything that we're doing and come up with a cohesive plan. And we want to try and consolidate everything obviously as best as we can, so we've got fewer systems, but we also want to have a common vision and a common set of platforms and technologies that we're all able to work off, and that really enables us to do our work more efficiently, enables us to build things more rapidly, and also sets up, I think, to be a bit of a leader across the New Zealand government to say this is the blueprint as to how you can do it. Of course, like everyone's doing it today, we want to bring AI into the mix. We want to try and leverage that as best as we can. There's some traps and some issues in there, but there's definitely efficiency gains and benefits to be had. So what does success look like for us? Where are we going with this vision? Well, our key goals is we want to consolidate our platforms. We want to get that central data management capability in place so all of the systems are feeding into one place and we can coherently see everything and see the metadata. From the external perspective, LINZ has got a lot of products and services. You come in and you maybe want to find a chart or a map. Maybe we've got 3, 4, 5 ways to do that at the moment. So we really want to streamline that, and we'll use this technology change as an opportunity to do that. We obviously want to upgrade our technology stacks, try and leverage the cloud as much as possible. We're a really, really big open source shop, but we're also pragmatic as well. We understand that we can't be running the Nat'l, we can't be running Kubernetes clusters, we can't be doing all that stuff because that takes us away from the key business value that we're going to be trying to solve. So we have to leverage the cloud as much as possible. We want to try and get reusable components as much as possible. Don't try and create things twice, but in some cases we may be still doing that. We want to leverage AI, and really, really important, I think this is probably one of the most essential things, is to get this done, we don't want to be using contractors and vendors. We have to do this with in-house capability. One of our key areas that we'll be leveraging is AWS. That's our key cloud platform that we want to go to. We've got a lot of skill in there, but we've still got a bit more maturity to go in terms of trying to get our best practices in place there. So this is a bit of a high level view, really the sort of the top 5 areas that we want to try and consolidate on our platform areas. This is still draft at the moment, but this is kind of the target that we're trying to vision ourselves around. So if you think about those 140 things, more or less probably about half of those things we can see consolidating down into these 5 things. I won't go into too much detail. I'll talk a little bit about them in future slides, but one of the key pivots to make all of this happen is the geospatial data lake at the centre. And the geospatial data lake is more of a concept rather than an actual, a shrink wrap platform. But in essence, the way that we're going to construct it and put it together, it's going to be the hub to make things really easy to work in that cloud native environment. So this geospatial data lake, well, what is it exactly? Well, fundamentally, it's going to be on AWS, it's going to be leveraging S3 buckets. This is all kind of common, well-established patterns for almost a decade or more now, if not longer. But we're also going to be leveraging the geospatial cloud native movement and technologies to really make that happen. In the past, trying to do a data lake often involved having to set up a whole lot of complex systems and have teams running those things. The goalposts have shifted in the last few years where actually it can just be an S3 bucket and it can just be some file formats sitting in there, and leveraging some other ingredients from the cloud, you can get up and running with a pretty comprehensive data lake. Some of those geospatial cloud native formats, we're building on the shoulders of giants here across the whole community of lots of people here, but we've got things like STAC metadata, we've got cogs, we've got PMTiles, we've got all those sorts of things. Pardon me. So this is the key building block for us, and we see our data sources going in there. And to remove that middleware and complexity that we've got a lot of, we've also got a lot of things in desktop environments. We see that we want to produce as many lightweight, thin clients that directly talk to the data lake. We've got so many apps that don't actually need to write anything, they actually just read things. So leveraging this pattern of a thin client directly reading these cloud-optimised formats straight in an S3 bucket removes the need to have middleware. We also see that this is not just an internal thing, but also leveraging things like the Open Data Registry and AWS, we see that the public can also come in and access these cloud-native geospatial formats. So, we see that, in open source tooling as well as in commercial products, there are a lot of tools now that just enable you to in place use that, doing queries, doing analysis, doing mapping. Got a couple of examples up there on the screen. So just in short, this is reasonably complex, but obviously the way that we see our future architecture, we've got the data lake at the center, got all the metadata and the key geospatial file formats in there that are driving it. We do see that it's not like a one bucket to rule them all. We've got many business domains, so it'll be a mesh of many business kind of like buckets, across topography and hydrography and stuff, and they'll all have like slightly different like file structures and object paths and things like that, but they're essentially be the same, and then we'll federate those all together and have like a basically an overarching catalog and probably STAC API that gives you access to all of that information in a coherent way. So the key shifts is we want to move all of our data in there, get to the geospatial format, and make sure that it's broken up by those domain boundaries when we share it. One of the key things that we plan on doing, and this is like a cost savings thing and also enables it to get used as much as possible in the out there in the wild, is that we'll be leveraging the AWS open data program. So that enables us to host all of the data on AWS for free, and also the egress is free. So anyone that comes in and like downloads our data, we don't need to get charged for that. It has got a slight benefit that, if you're on a different cloud platform, whatever, it's not quite as good as if you're in AWS, but still enables you to take the data away if you need. So we've got plans to redo some of these platforms. It's part of these redevelopments. We see that that we're going to be building the data lake into those processes. So when the data comes in and we save it, it's going to go into the data lake as part of that process. So that's going to be the key thing. First cab off the rank, we're really going to use it in anger, and a transactional system is going to be our topographic system redevelopment that hopefully you'll hear a little bit more about next year. Our data publishing, we've already got well-established data publishing workflows through the LINZ data service, but we want to get it more tightly integrated, get the primary source coming from our data lake. We also want to leverage web mapping services. We're going to reimagine our web mapping stuff. So, we're already a big user of map library and these types of things, but we want to get ourselves a platform that enables to leverage the cloud native formats directly. Get rid of as much middleware as possible. Whoops. And then our other systems will come on board. They might not be able to use the cloud native formats, like in its core operations, but they'll definitely be able to save its data in there. And in some cases, in read-only context, they'll want some of the information to display in maps or into search widgets. One of the common things that we plan to do, and I'll talk a little bit more about this later, is that we want to put basically a common spatial data pipeline or workflow system in place. Quite a few agencies have already done this. We do it with Argo, and we just basically have a template for when we're getting data from one place to another, and we put it through that. To make this happen, and I talked about this before, but to lift our maturity in using the cloud and to get ourselves basically what we call the pit of success, or our common ingredients for building our apps, we need to get some common components in place, which embarrassingly we still haven't got all of those done. So we're going to be trying to focus on getting those so that when we're rebuilding these apps, we can reuse these building blocks. I won't go into detail, just flash that up on the screen, but this is our default stacks that we'll be planning on using. It's not singular. We've got some of our business domains with capabilities around certain areas. So in some cases, we've got a team with Superbase. In other cases, we've got full-on AWS engineering teams. But pretty much, if you look across the board, those are the common stacks that we'll be targeting and using. So what's the secret ingredients? Well, it's not really too secret given this community, but for us, we see that open source first. That's a really key strategy for us to make this happen in-house. We want to avoid contracts, vendors, and we just want to be able to have the ability to control our destiny with some of our mission critical systems, and open source is a key ingredient. We've had that strategy probably for about 10 years now, but it's definitely bubbling more up to the top as we get more serious here in redeveloping our systems. Cloud native platforms, as I said, that's definitely what we see as super important, and I'll talk a bit about that in the next point. But and really the other thing which I touched on before is in-house capability. Getting the developers in-house, building that expertise and that knowledge gives you the capability to be able to develop at more pace with innovation and to not have a big bang project approach to things. The number of IT projects in government that have failed because they got too big and expensive and had too many large procurement processes on them is endless. If you just have an in-house capability and you say, this is our mission, this is our BAU way of working, you can incrementally basically tackle the problem over multiple years and not get stuck in doing requirements and business cases. And we see that the cloud is essential to support that happen in an efficient way. I won't touch on this too much due to time, but we do have an open source strategy now in LINZ. It's open source first. We still have some proprietary stuff, but when we're building our key mission in-house things and operating it, that's the secret sauce that goes in. Just quickly, what's the progress? We've already started doing some of this over many years, and Jonathan will talk a little bit more about one of these products coming up, but our LINZ base map service is very much cloud native. It's leveraging basically like cogs and STAC in an S3 bucket, and then our tiling service is just a simple lambda. We have less than a quarter of a person needing to actually maintain this thing, but it's going at huge scale. It's like got huge value, huge number of tiles, and it's low cost for us. So this is an example of how it's working. Jonathan will tell you all about it coming up next. Also, in terms of the way that we're processing our data, we're taking it from our suppliers and we're doing our quality control. We are converting it into our cloud native formats. We're generating our metadata and we're sticking it out into the Open Data Registry. It's all done through our Argo process. We've got that in place now for our imagery workflows. If you want to know more about it, talk to Daniel there in the back later. But we're also started doing our imagery in there. We're about to put our LiDAR through, and the vision is that we're going to get all of our pipelines going through this for all of our data sets and all of our domains. The great thing about this is it's able to work at scale. Its maintenance is reasonably low, although we're probably like AWS to give us an Argo as a service, but we're not quite there yet, but it's able to process super large data sets in minutes and give us scale and give us more agile feedback to our people that need to QA things. It's really working out super. So just a bit of a plug, but here's a couple of the data sets which have been generated from LINZ and put out onto the Open Data Registry, so you can go to those two sites there, see it. And you'll see that they're in cog format, and we've got certain specifications around the compression and the dimensions and those types of things in there. And we've also got the STAC metadata in there. So that's really the start of our data lake. The plan is that we're going to build that out, do it for all of our public data as well as some of our internal data, and bring that together into a cohesive platform for us. So that's it from me.
Any questions for Jeremy?
Thanks for that really interesting talk. It seems like you're a bit ahead of us at Sciences New Zealand with where your thinking is, so I think we can learn quite a lot from where you are. I was wondering, with your kind of cloud-based approach, is the idea that your internal users and external users will all be accessing data that way, or will you have it separate for internal users?
Yeah, so the platform as such will be available for internal and externals. There'll be different mechanisms to do it. So with the public stuff and going into the Open Data Registry, all of the buckets and then hence all of the requests will be able to be done with without having to be authenticated onto the platform, right? but for when they're accessing the metadata and the data in private buckets, or even what we might call internal buckets, because I think we'll also have some government partners that we'll share stuff with, as well as just our internal teams. That will definitely be behind an authentication system. But the structure and the way of accessing it will be consistent with what we do in the public forum. Also really happy to have a conversation at any point in the future. Yeah.
Great talk. You mentioned building capability and also talking about, I guess, what your overall vision is. How big's the team?
So the team at the moment is, I think it's about 22 at last count. I think we're getting another couple at the moment to help out with our marine transformation program, but it's 22 at the moment. I think there's 3 architects. We got 4 like product owners or work leads, and then the rest are developers. So that's the size. So the plan is that we want to make a case for a few more, but that's probably about the size it's going to be.
Any more questions?
Any words of advice for other government departments wanting to build strong in-house capability? I know the needs are all very different, but to be quite lacking across the board, I feel.
Yeah, I mean, like the main business benefits are that you're able to maintain your products in perpetuity, right? And you're able to basically keep them maintained to best standards and delivering the best things to your customer. Often what happens when you do these like big IT projects where you build something and you finally get it across the line, if you do get it across the line, is the project or the program ends, the money runs out, there's a little bit of money there for BAU to maintain it, but generally the product like runs into the ground over the next 20 years or so. And so the main thing here will be about basically trying to make sure that you can deliver a great like modern platform, but keep it maintained into the future so that it doesn't fall into disrepair. It's a bit subjective, but I would definitely say that it's more cost efficient to go in-house. What senior leadership often worries about is what about the risk of trying to build that capability and attract that talent and maintain it. So those are some things that you've got to get right. But if you can get the expertise in-house to lead that and get the in-house capability, then it'll most definitely pay off.
Hi Jeremy, I was just wondering, what are the biggest challenges that you anticipate facing in order to fully realise your vision for all of your business group and then rolling out to the rest of LINZ, if that's the goal?
Yeah, the biggest challenge is always on the resourcing balance versus the amount of work that you've got to do, right? So at this point, I'm selling a vision. We've got some more detailed roadmaps in behind there, but even then, there's still things where you can never lock down the confidence on delivery of things. So, we're going through the process of making, some internal business case around the benefits of like going towards this vision and the cost savings and the customer value that we're going to be given. So the trick will be trying to prioritize to get that business value actually happening as soon as possible so that we can continue to build confidence in the pathway that we're going.
Any more questions? I've got. Oh, sorry. This one.
Thanks for sharing the strategy. My question's around funding of open source projects. With your open source first strategy, is there any chance that you'll have any way to, with your limited budget, get any of that towards OS programs?
So we very much, while we are leveraging open source, we very much see it first and foremost that we contribute back to the open source community. That's a key thing in terms of making sure that the community is healthy and also building trust and relationships as well in the way that we work. So for many years we've treated that as essential, and so what's happened in the past, and there are always procurement, like bottlenecks or issues that we have to work through, but we've worked through most of them as they've come our way, is that we've tried to do the strategy of at least fund a feature. In more recent times, we've been able to move towards sponsorship, and that's gone through some more leadership and procurement activities, but we've been able to justify that. So, for example, we're now a sponsor of the GDAL project. We're also a sponsor of Cloud Native Geospatial Forum, and we'll be looking to the future to try and become members of other critical technologies that we leverage. It's always an ongoing thing, but I think we've been through enough hurdles and stuff that I think we're past that stuff now, so I think it should be good.
One final question over there, then I think we're out of time. I did have a question myself, but I'll ask that offline.
That was really interesting. Just wondering if you guys have ever actually quantified the savings you've made by taking an open source approach as opposed to relying on proprietary software for everything.
Probably in short, we haven't done a holistic study on it. We've done it often on case-by-case, project-by-project basis, trying to prove the value and the cost. So for example, we've been through that just with like setting our high-level direction for the topographic mapping system. We also did the same for the revamp of our land online system, but we haven't got a holistic kind of like paper or report that shows that. And even if we were to go to those particular projects, I think a lot of it probably happened in rooms. There were some things that were documented, but we wouldn't have anything that we'd be able to nicely share with you, for example, or put out. But it's something that we always think about, and we always run out of time.
All right, I think we might finish up there. So please join me to thank Jeremy.